All right, Algebra 2, this is page number 12. Both of these questions, number 30 and 31, we have not covered yet this year. So I'm going to take just a little bit and teach you how to do both of these questions. So in New York State, the minimum wage has grown exponentially. That's going to be huge for Algebra 2, okay? Exponential. In 1966, the minimum wage was $1.25. In 2015, it was $8.75. So remember on that last page, I just told you how to get from one number to the next. You do it by dividing, okay? So this would be further on down the list because it's happened more recently. So we would take 875 and we would divide it by 125. Now here is the problem. Okay, if you straight up divide those, that's actually not going to tell you what number you multiply by or what growth you are going to be seeing over that time span, because remember also on the last page, I told you that these two numbers had to be one right after another. Well, 1966 and 2015 are not right next to each other. 2014 and 15 or 1966 and 1967. So what we have to do is we have to put an exponent up here, okay? I want to know the value of growth in 1 year when they give you, oh gosh, how much of a time span is that? So from 1966 to 2015, I'm going to subtract those two. So 2015, 1966, that happened over 49 years. So I want to know, what is the 1 year growth rate when they're giving me 49 years? So that's an exponent up there, okay? So when I type that into my calculator, okay, 875 was the most recent price. $1.25 was the earliest price I knew. And I want to know in the exponent, what's the value of 1 year of growth when they gave me 49 years? There you go, 1.04051. Now here is the next thing we need to know. Remember that 9th grade formula I taught you? Starting amount, 1 plus, it's growing, so I'm going to go plus the rate to the amount of time. This basically is off of that formula, and you could actually use this formula to find that number. So notice the number 1 is in the formula. That is 100%. So how much did it grow? This much. So if I move that decimal 1, 2 places, I know that it grew 4%. Okay, that's a little bit weird. That's something new, and I just threw it at you in under 3 minutes. So if you need more talking about that question, if you have any questions, let me know. This one, I mean, we've discussed a little bit about functions being odd or even, but we've never talked about it algebraically. That's coming up actually really, really soon. So what we have to do is we could graph it. That's not algebraic, but we could graph it. Even functions are symmetric about the y-axis, I'm going to say. I think it's y-axis. Odd functions are symmetric around the origin. But to do it algebraically, what you're going to do is you're going to take this function and you're going to plug in negative x. All right, so everywhere you see an x, I'm going to put a negative x. Okay, now I'm going to evaluate it. Negative times negative is positive, times another negative is negative, times the fourth negative is positive. Okay? Negative times negative is positive. So negative 3 times positive is negative 3x squared. And then that's had nothing changed. So if I evaluate when I plug in a negative x, I end up with exactly the same thing that I started with. When that happens, when you end up with exactly the same polynomial back, your function is even. Okay? If you do this and you got opposite, so this would end up being negative x to the fourth. This would end up being plus 3x squared. and then that just stays. Oh no, it would end up having to be plus 4. It has to be plus 4. Every single term is opposite. That would be odd. All right. If you get a mixture of the two, that's when it becomes neither. Here's a little clue for you. Notice how all of the exponents that you see are even. If every exponent you see is even, the function is even. So here's an example. X to the 4th plus 3x squared. Boom. That's going to be an even function because everything is even in the exponents. X to the 6th plus 4x to the 4th plus 8x squared. See? Even, even, even. This would be an even function. All right? Odd functions, if all of them are odd. Notice I'm using plus signs. That's just because. So the exponent is 3. The exponent is 1. All of them are odd. Function would be odd. All right? I'm going to throw minus. Plus x. Odd, odd, odd. That's an odd function. All right? If I mix the two together, even, odd, this one would be neither. N-E-I-T-H-E-R. There you go, neither, because it has a mixture. All right, so if you want to algebraically determine, put negative x everywhere you see an x, evaluate them. If you come out with exactly the same polynomial, your function is even. If you come out with a polynomial that is complete opposite, you would have odd. And if you have a mixture of the two, you have neither.